Bismillahirrahmanirrahim. Today we will discuss an easy and quick way to find the matrix inverse of a 3 by 3 matrix. For example, if we have this 3 by 3 matrix, A equal 1 minus 1 1 0 2 minus 1 2 3 0. It is a 3 by 3 matrix. Find the inverse of the matrix A if it exists. We know that the matrix, the inverse of matrix exists if and only if that the determinant of the matrix A not equal 0. So we have firstly to calculate the determinant of this matrix A and to be sure that this determinant not equal 0. Determinant of A, det A equal, we can expand this the determinant of this matrix from the elements of the first row. Our signs plus minus plus of the determinant, so we have plus multiply 1 1 is multiplied the element 1 multiplied by its minor. The minor is obtained by eliminating the first row and the first column, so the remaining determinant is 2 minus 1 3 0 0 multiply 0 to 0 minus from the rule 3 multiply minus 1 minus 3, so we have minus 3 multiply minus plus 3. Our rule of sign in the first row, plus minus plus, so we have minus from the rule, multiply the element minus 1. This minus 1 will be multiplied by its minor determinant, which is obtained by eliminating the first row and the second column, so we have 0 multiply 0 0 minus from the rule 2 minus 1 minus 2 multiply minus plus 2. Finally we have this element 1. Our rule again plus minus plus, so we have plus 1 multiplied by its minor. The minor is obtained by eliminating the first row and the third column, so the remaining determinant is 0 2 2 3. By expanding this minor, we have 3 multiply 0 equals 0 minus from the rule 2 multiply 2 4. So simplifying this quantity, the determinant of A equals 1 multiply 3 3 minus multiply minus plus 1 multiplied by 0 plus 2 2 plus 1 multiplied by minus 4. So we have det A equals 3 plus 1 multiplied 2 minus 4. The result is 5 minus 4 يعني equal 1. Now since the determinant of A equal 1, so this number not equal 0, so the matrix A has inverse. A inverse, the A inverse exists, so we can calculate the inverse of this matrix because we find that its determinant not equal 0. Okay, now I will discuss the easy way to find the inverse of the 3 by 3 matrix. It is obtained from this rule: A inverse equals edge A, the adjoint matrix of A, over det A. In our example, we have already calculated, in this example, we have already calculated det A, which equal in our example 1. So we will put 1 here. Now we need to calculate this matrix, adjoint A, adjoint matrix of A. To calculate this matrix, first we write, this is an easy way to find this adjoint. We write again the matrix A, 1, يبقى to find adjoint matrix of A, we write the elements of A again. Look, this is the element of the matrix A, 1 minus 1. I need some spaces to simplify the calculation. 1 minus 1, 1, again 0, 2 minus 1, 2, 3, 0. This is the elements of the matrix A. Now our method is as follows. We will write the elements of the first column again. This is column number 1. We will write again the elements of column number 1. Look, 1, 0, 2. We repeated the first column. Then we will repeat also the second column, this column number 2. We will repeat the element of, so we will repeat the element of column 1 here. We will repeat the elements of the column 2 here, minus 1, 2, 3. This is the first step. Second step, the rows here, we will add 2 rows here. The first row, all this row, and the second row, all this row. So after adding these 2 columns, by repeating the first column and second column, we will add 2 rows here, the first row and the second row. So repeating the elements of the first row, 1, minus 1, 1, 1, minus 1. This is the first row, is repeated again here. Also we will repeat the elements of the second row. 0, 2, minus 1, 0, 2. Now we will delete the first row alongside the first column. This will be deleted. No need to use. Cancel, cancel. So we will construct our adjoint matrix from the remaining elements. This row, this row, this row, and this row. How? By making the adjoint matrix is a matrix like this. The elements of the adjoint matrix will be obtained by making some calculation on the row wise of these remaining elements. For example, the element of the first row here in the adjoint matrix will be obtained by making this calculation from the remaining first 2 columns, this column and this column, like this. We make multiply internals by terminals. Like the process looks like expanding the 2 by 2 determinant. Look, from these 2 elements, we will make we will multiply the terminals by minus internals. So 0 multiply 2, 0. 0 multiply 2, 0. Minus, like the determinant, 3 multiply minus 1, minus 3. So the overall result is 3. We repeat this process. Column-wise calculation will be written here as row-wise entries. Again, 0 multiply 2, 0, minus 3 multiply minus 1, يبقى the result is 3. To find the second element in this row, we again do the same calculation. We will multiply 1 multiply 3 minus 0 multiply minus 1. 1 multiply 3 3 minus 0 multiply minus 1 0 يبقى the result is 3. I remind you we make the calculation column wise and we write the entries here in the adjoint matrix row wise. So finally, to find this element in the first row, we will multiply minus 1 by minus minus 2 multiply 1. Minus 1 multiply minus 1 minus 1 multiply 2 يبقى the result equal minus 2. 1 minus 1 multiply 1 minus 2, the result is minus 2. The result is minus 1, not minus 2. 1 minus 1 multiply minus 1 minus 2 multiply minus 1, so the result is minus 1. Again, to find the elements of the second row, we will repeat the process between these two columns, this column and this column. So our calculation are column wise and our entries are row wise. 2 multiply minus 1 minus 2. Minus 2 minus 0 is minus 2. Because 0 multiply 0 is 0. Again, 0 multiply 1, 0, minus 1 multiply 2, 2, يبقى 0 multiply 0 multiply 1 multiply 0, 0, minus 1 multiply 2, 2, so the result also minus 2. Similarly, we multiply these two elements minus these two elements. 0 multiply 1, 1, minus 1 multiply minus 1. So 0 multiply 1, 0, minus 1. So the result is 1. Finally, to find the elements of the third column in the adjoint matrix, we will repeat the procedure. We will multiply this element column wise, then write the entries row wise. 3 multiply 0, 0, minus 2 multiply 2. So 0 minus 2 minus 4 equal minus 4. Again, we will multiply 2 by minus 1. This is minus 1 multiply 3. So minus 2 minus 3. The result is minus 5. Finally, to find this element, we multiply 1 multiply 2 minus 0 multiply minus 1. So 2 multiply 1, 2, minus 0 minus multiply minus 1 equals 0. So the result is 2. Now this is our adjoint matrix. 3 minus 1 minus 2 minus 2 1 minus 4 minus 5 2. From our rule, again the inverse of the matrix is the adjoint matrix, which has already been calculated, over the determinant of the matrix. We have already found the determinant in our example is 1. So the inverse is the adjoint matrix over det A equal 1. So it is adjoint matrix over 1. So in this example, A inverse is the same as the adjoint matrix 3, 3, minus 1, minus 2, minus 2, 1, minus 4, minus 5, 2. This is our, the same like this. The same like adjoint matrix, because A inverse equal det A equal 1. Also we have a Matlab code to find the inverse of this matrix. This is a built-in Matlab code to find the adjoint of this matrix made by me, and here we write our matrix, which has already been solved. Then we write the condition for existence of the inverse, the determinant must not equal 0. If the determinant D equals 0, then there is no inverse of the matrix. B here is the inverse of the matrix, and its command is mva. So running this code easily, we have D equal 1, as we have already calculated in our previous calculation. So we expect the inverse of the matrix. It is B here, 3 minus 1, minus 2, 1, minus 4, minus 5, 2. This is typically what we have already calculated in our previous calculation. And this is an easy way and a quick way to find the inverse matrix of a 3 by 3 matrix, but not for any general n by n matrix. Thank you very much.